Hey guys, welcome to Study Guide. Let's go. Alright, first one, cross multiply. So make sure you have your calculator ready to go. So 9 times 52, turn it on, is 468. When you multiply these, you have to distribute, so it's 39x minus 39 times 4, which is 156. And then we're going to add that 156 across. And we're going to get 39x equals 624, and divide by 39. X equals 16. Alright, number 2, are they similar? We got to check to see if the sides are proportionate. So we're going to take the large side and compare it to the large side of the two triangles, and we're going to take the small side and compare it to the small side of the two triangles. And so we get 4.1 over 2.5 equals 3.2 over 1.6. Notice I went from left to right, so left to right, left to right, left to right. We cross multiply. When we cross multiply here, we get about 6.5 equals 8, which means they're not proportionate, so they are not similar. In this one, we actually do have similar triangles, so again, we're going to try and figure out how we can set something up. So what would x match up with? X would match up with this whole piece. So the bottom big triangle to the top of the big triangle, that would be 21, 6 plus 15. And then the bottom of the little triangle would match up with the top of the little triangle. And so we can go x over 21 equals 20 over 15. And again, I went from bottom to top, then bottom to top for each of those. You cross multiply, you get 420 equals 15x, and then divide x equals 28. Given, solve for x and y. So we have a similarity statement. So like AB is the first two letters, has to match up with ED. So we know those are going to match up. And then we can see BC is going to match up with DF, and then the one I haven't highlighted is going to also match up. So we can set up proportions to solve this. I can go 9 to 3, so I'm going to go left to right equals left to right. And we cross multiply, we get 45 equals 9x, and then x equals 5. And then we can do the same thing to solve for y. I'm going to use the 9 over 3 again, because I can't have two unknowns. I'm going to go y to 4. So we're going to get 36 equals 3y, y equals 12. The three postulates to prove triangles are similar are angle similarity, side angle side similarity, and side similarity. What postulate can prove these triangles are similar? Well, we see that there's an angle in between. I'm thinking it's going to be side angle side, but we have to check to see if our sides are proportionate. So I'm going to take the large side and compare it to the large side. Again, I don't just pick it because I think that looks like it. I'm picking the big to big, and then I'm going to go small to small. And so we get 20 over 15 equals, so I did 20 to 15, so I have to go 16 to 12. When I cross multiply these, I'm actually going to end up with the same value. So 20 times 12 is 240, and 15 times 16 is also 240. So we do have proportionate sides and angles. So this is side angle side similarity. This one's really easy. We have the two angles congruent, so that's angle similarity. How can we prove these? I'm guessing it's going to be side similarity, but let's go ahead and match them up. Again, large with large. Suggestion. No suggestion. Look at, they're trying to make me update my computer. I ain't got time for that. Okay, so I'm going to go 21 to 14. You're going to probably start noticing a pattern here if we can. And then we're going to compare the 6 to the 4 and 15 to the 10. So if I simplify 21 over 14, I get 3 over 2. If I simplify 6 divided by 4, I get 3 over 2. And if I divide 15 by 10, I get 3 over 2. So they're proportional by side similarity. Number 9. So again, we have actually a small triangle and a large triangle. So I have the bottom piece compared to this piece. That's the bell. And then we have this side piece to this side piece. So we can actually find this. AD by using x. So we can go, I can go 10 to 30, so little to big, equals x over 21. And cross multiply, we get 210 equals 30x, x equals 7. That's AD. Now, BC is this little piece, but I'm actually going to solve for this whole thing right here, which I'm going to call y. And the reason why I'm going to do that is because I can compare this little side to the whole side, just like I did over here. And so that would be, again, 10 over 30, so the little piece to the big piece, 6 over y. When I cross multiply this, I get 10y equals 180, y equals 18. So if 18 is the whole thing, I can actually take 18, subtract the 6, that gives me 12 for BC. Again, not to scale, but it does work. Tree casts a 30-foot shadow at the same time a person is 6 feet tall that casts an 18-foot shadow. How big is the tree? So we can draw a tree with a 30-foot shadow. I could draw a person that's 6 foot with an 18-foot shadow. We want to find x. So this is a proportion. What I like about this picture, it kind of looks like it's already set up. X to 30 equals 6 to 18. Okay, we cross multiply that. 6 times 30 is 180 equals 18x. X equals 10 feet, or the height of the tree is 10. What is Pythagorean theorem? A squared plus b squared equals c squared. We're going to use it like on a problem like this one. That's going to be 8 squared plus x squared equals 17 squared. So that's 64 plus x squared equals, what's 17 squared? I don't remember that one. 289. Subtract the 64 from both sides, and we get x squared equals 225. Square root of x equals 15. This one says leave an exact form, so I'm assuming we're not going to get a whole number here. So we get 10 squared plus 11 squared equals x squared. I'm going to do those two at the same time. 10 squared plus 11 squared is 221. Now, if you have a fancy-dancy calculator, you can just take square root of 221, and it will show you what its simplified version is, which happens to be just square root of 221. Number 14, we want to check to see if these are triangles. To see, we want to look, are these two bigger than this one? So that's 18, yep. That's 21, yep. That's definitely. So those are definitely triangles. Next, we check to see what kind of triangle they are, so we compare. So when we compare these triangles, we notice that on this side we're going to get 8 squared plus 10 squared, which is 164, and 144. So the little guys win the war, so we call it a cube. So the two little guys are bigger than the big guy, so it's a cube. This one actually ends up being a right triangle. How we do that is 9 squared plus 12 squared compared to 15 squared. They actually are both 225, so if they're equal to each other, it's a right. And last but not least, 31 plus 35 squared. Let's see if I can actually type it in my calculator correctly. So we get 31 squared plus 35 squared is 2186. And then 39 squared, 1521. So again, the little guys win the war. It's acute. If the big guy was bigger, we would call it obtuse. 20-foot ladders leaned up against a house. So that's my 20-foot ladder. It's 9 feet away from the base. How high up does a ladder go? Pythagorean theorem. So literally we just do x squared plus 9 squared equals 20 squared. So I'm actually going to do 20 squared, and I'm going to subtract 9 squared from it right away to get x squared equals 319. So the answer is actually square root of 319. That happens to not simplify, or you approximately get 17.86. Round to the hundredths. Ooh, okay, can I get through them all? Let's see. I'm doing good. I'm trying to go fast. Given the triangle, solve for x and y. So this is in the LRAD2 position, and this is L and L. So if you have 10 in the LRAD2 position, you're going to divide by 2, multiply by RAD2. So you should get 5 RAD2, 5 RAD2. This one's even easier because it's L, L, L RAD2, so this is going to be 8, and this is going to be 8 RAD2. This is 2L, this is L RAD3, and this is L, so we should get L to be 9, and then this is 9 rad 3. And this is L rad 3, L and 2L. And so just like the one we did before, we're going to divide by 3, multiply by rad 3, so this is 3 rad 3, and this is 6 rad 3. Double it. Okay, that was fast page right there. Alright, sine, cosine, tangent. So it says of angle A, so we're going to put the eyes here, so it's opposite, hypotenuse because it's across from the 90, and adjacent. So it's SOHCAHTOA. And so we have opposite over hypotenuse. So that's just going to be 12 over 37. Then this is adjacent over hypotenuse, that's just 35 over 37. And then over A, 12 over 35. Alright, this triangle, we're going to set our googly eyes. We have opposite and hypotenuse. We're going to do sine of the angle, 37, equals opposite over hypotenuse. When the x is like that, we can just flip-flop. So we get x equals 23 over sine 37. And if you plug that into your calculator, we are going to get about 38.2. And that seems to be big, logical. It's bigger than this, so I'm okay with that. Another googly eyes, we have opposite and adjacent, so we're going to do the tan of x equals 29 over 21, opposite over adjacent. To get rid of tan, we're going to use the inverse tan, so we actually end up with tan inverse 1 of 29 over 21. So in the calculator we go. We're going to get 54.1, and we'll call it there for right now. Alright guys, I'll be back with the next group.